Hi, this is Jeff Spence, your Math 120 instructor for the Community College of Denver, and this is our second part of the video lecture over 4B, second part. So in the first part, we covered these two examples where we wanted to see, using the savings plan formula, we wanted to see if we know the monthly payment over a certain period of time, we wanted to see what it can grow to if it compounds interest and we make regularly scheduled payments. Remember, that's different from this formula because this formula here was assuming the P is a one-time initial investment formula or value. That's what the principal stands for. So this particular problems that we're going to work on now are using Formula 8, where we might know the amount that we want to save for, and we want to see if we can budget it out of our paycheck by solving for this regularly scheduled payment, seeing if we can seeing if we can budget that out and seeing what we have to make as regularly scheduled payments given a future value amount. So here's number 3. It says you intend to create a college fund for your baby. If you can get an APR of 3.5% and want the fund to have a value of $173,079 after 6 years, how much should you deposit monthly? What interest did you earn? So this is what we want it to grow to, so we know the amount. We don't know the regularly scheduled payments, so that's why we want to use Formula 8. So let me copy that over so you can see it as I write the stuff in there. So we're trying to figure out the payment so that we can save for, or eventually have, $173,079. Okay. Oh, I forgot. I got to do the N times Y. So remember, we're on a monthly schedule, so that means N is 12, and we're talking about 16 years. So 12 times 16, let me plug that in real quick. 12 times 16, 192. So we're going to make 192 payments over the 16 years. Alright, so let's plug this formula in. So 173,079. The APR is 3.5%, so that's 0.035 divided by 12. Divided by another double parenthesis here, 1 plus the APR, which is 0.035, divided by 12 again, to the exponent key, 192. I did that off to the side. Please remember to do that. Minus 1. And that's our formula there. So let me start typing that into the calculator. So I have 173,079 times 0.035 divided by 12, and the parenthesis, and then divide again, double parenthesis, 1 plus 0.035 divided by 12, and the parenthesis, to the 192 minus 1, and then end that parenthesis. And that would tell us that we need to make regularly scheduled payments of $673.76 to the nearest cent. So $673.76. Let me double check that. Yep, okay. Alright, so to figure out the interest now. So remember, the interest is always the amount that we're aiming for minus the total payments. So the amount that we are aiming for was the $173.79 minus the total payments. Well, we made monthly payments of $673.76 for 12 months each month for 16 years. So let's figure out that amount. Now remember, I'm going to take this answer and I'm going to round it to the nearest cent. I'm not going to use this answer, so I'm going to take the 673.76 rounded to the nearest cent times 12 times 16. And that tells me that I need to invest $129,000 over the period of time, over the 16 years. I'll invest $129,361.92. So I need to do the $173.79 minus the $129,361 $40,000.92, because that's all the money I put down, and it grew to this amount, so the interest would be $43,717.08. So $43,717, how many cents again? 8 cents. So over 16 years we made $43,000 in interest by making monthly payments of $673.76. Alright, let's do the last one here. So the last one says, how much should you deposit into an account paying 4.9% interest compounded quarterly if you want to have $10,000 after 15 years? So this is the example I was kind of saying before. If you know you want to make a down payment on a house in a certain period of time, here's what you have to figure out. So once again, we're going to use the same formula here, the payment formula, because we know what we're saving for. We want to figure out how much we have to save to get that amount. So the amount is $10,000. The APR is, oh, I forgot to do n times y. I got to do that. N times y. All right, now this time it's compounded quarterly, so n is 4. And we're doing it for 15 years, so 4 times 15, that equals 60. Okay, so let's type it in the formula. 4.9 interest, 0.049 divided by 4, not 12 because we're doing quarterly, divided by, again, double parenthesis, 1 plus the APR, which is 0.049, divided by 4 again, to the 60th, minus 1 and the parenthesis. Alright, now let's type that in. 10,000. Oops, I put in too many zeros, so I can go back and just put the parenthesis over that. 10,000 times 0.049 divided by 4, and that parenthesis, divided by parenthesis 1 plus 0.049 divided by 4 again, and the parenthesis, to the 60th minus 1 and that parenthesis. And this says that we need to invest $113, and if you round it to the nearest cent, that's 83 cents. So we would need to invest each month $113.83. Let me double check that. Yeah, okay. Which isn't much. You know, if you think about it, if you're young and you want to start investing, all you have to do is put down about $100, and it'll turn into $10,000 after 15 years. And that's just on a quarterly compounding schedule. So let's figure out our interest. Remember, our interest is what we were aiming for, the $10,000. It grew to that amount, minus the monthly payments, or minus the total payments, excuse me. So monthly payments, or no, sorry, this is quarterly payments, so times 4, and then times 15. Oops, I got to put in the cents there. 113.83 times 4 quarterly payments for 15 years. Okay, so let me type that in using the rounded answer. 113.83 times 4 times 15. Okay, so over the period of 15 years, we actually just paid $6,829.80. So that grew to 10,000. So the interest would be the difference, $6829.80. $3,170 in interest. 3,170, and how many cents here? 20 cents of interest. So follow the examples carefully, use the formula sheet, and you can use that on the exam. Just make sure you follow the parentheses and the powers and every symbol exactly the way it's written. And good luck. We'll see you next time.